Hi guys, and this is Andrea Spar for my presentation about aspirin, the miracle drug, for Professor Bayo's class. Arachidonic acid, prostaglandins are unsaturated carbolic acids consisting of a 20-carbon skeleton that also contains a 5-member ring. They are biochemically synthesized from the fatty acid arachidonic acid. You can see the graph over here. The unique shape of the arachidonic acid caused by a series of cis double bonds helps to put its position to make the 5 ring. Arachidonic acid is synthesized from alpha-linolenic acid derived from linolenic acid and is an essential fatty acid by the enzyme 6-desaturase. Once formed, arachidonic acid can be converted to any of the eicosanoids. Cyclooxygenase is an enzyme that transforms arachidonic acid into endoperoxides, which are used to synthesize prostaglandins, prostacyclin, or thromboxanes. Drugs such as aspirin and indomethacin inhibit cycloogenase and block the synthesis of prostaglandins and thromboxanes. Certain flavonoids obtained from plants also block cyclooxygenase, a separate enzyme, 5-lipoxygenase, forms, and the leukotrienes from arachidonic acid. This enzyme is not inhibited by aspirin or indomethacin, but can be inhibited by a specific lipogenase inhibitors as well as by plant flavonoids. How does it work? Well, it works by inhibiting an enzyme that produces prostaglandins, hormone-like messenger molecules that trigger processes in the body and including inflammation. And then we'll discuss this structure of this picture in the next few slides. So aspirin acetylates the serine amino acid residue present in the active site of cyclooxygenase enzymes, both 1 and 2 isoforms of cyclooxygenase enzyme. Aspirin is mostly non-selective, but mostly inhibits COX-1 more than COX-2. So then you have the structure of aspirin, and then the structure of the 15-HT. And then the mechanism of the acetylation of COX-1 and COX-2 isoforms. The location of the serine residue in COX-1 and COX-2 varies. In COX-1, serine is present in the 530th position and 560th position of COX-2. So you have your salicylic acid, COX-1 going this way, inactive, which inhibits the prostaglandins 2, which inhibits prostaglandin synthesis. And then over this way we have COX-2, which inhibits prostaglandins 2, but actually produces the 15-HT, which is a new pathway resulting in the leukotriene synthesis. Aspirin is a non-selective COX inhibitor. Aspirin exerts its effect primarily by interfering with the biosynthesis of salicylic prostanoids, thromboxane A2, which is TXA2 that you can see, and then prostacyclin and other prostaglandins. These prostanoids are generated by the enzymatically catalyzed oxidation of arachidic acid, which is itself derived from the membrane phospholipids. Arachidonic acid is metabolized by the enzyme prostaglandin PG, which is, you can see over here, you got PG, PGH, PG2, PGH2. So PGH synthesis, which through is cyclooxygenase COX and peroxidase activities, results in the production of PGG2, which is over here, and PGH2, which is here in this diagram, respectively. PGH2 is then modified by specific synthesis, thus producing prostaglandins D2, E2, F2A, I2, which is prostacyclin, and TXA2, all of which mediate specific cellular functions. So here are your tissue-specific isomers. So PGI2 goes for the kidney, the brain. Thromboxane is kidneys, smooth muscles, platelets. Prostaglandin E2, brain, kidney, smooth muscles. prostaglandin F2 alpha, brain, kidney, smooth muscles. So PGH synthesis, also referred to as COX, which is COX, exists in two isoforms that have significant homology for their amino acid sequences. Here's just another diagram going further into detail of the breakdown of the chains. A single amino acid substitution in the catalytic site of the enzyme confers selectively to the inhibitors of the COX isoforms. The first isoform, COX-1, is constitutively expressed in the endoplasmic reticulum of most cells, including the platelets, and results in the synthesis of homeostatic prostaglandins, responsible for normal cellular functions, including mucosal protection, maintenance of renal blood flow, regulation of platelet activation, and aggregation. The second isoform, COX-2, is not routinely present in most mammalian cells, but rather is rapidly inducible by inflammatory stimuli and growth factors, and results in the production of prostaglandins that contribute to the inflammatory response. And here we get to where aspirin imparts its primary antithrombotic effects through the inhibitants of PGH synthesis, COX, by the irreversible acetylation of a specific serine moiety. In the presence of aspirin, COX-1 is completely inactivated, whereas COX-2 converts archaic acid not to PGH2 but to 15R hydroxysaturonic acid, which is the 15R-HETE that we saw, and I have that broken down over here in this photo. Other mechanisms for platelets inhibition by aspirin have been proposed. For example, aspirin facilitates the inhibition of platelet activation by the neutrophils, an effect that appears to be mediated by a nitric oxide dependent process. Inhibition of prostacyclin synthesis in endothelial cells enhances no production. Prostaglandins have vasodilatory action on the blood vessels, so the prostaglandins are one of the more potent mediators that cause increased blood flow and chemotaxis. Hence, increase the flow of more white blood cells in the mediators of inflammation. Therefore, prostaglandins increase the process of inflammation. So, inhibition of the prostaglandins by aspirin reduces inflammation, which in return can help reduce pain. Thank you for watching my presentation. I look forward to seeing all y'all, and there's only 2 weeks class left.